It's 2026 and drone data is now being applied to so many different types of sites and structures, whether it's mapping a particular type of site or it's inspecting a particular type of structure. You're sort of seeing drones being applied in every shape and form. One thing that still remains a challenge is being able to collect reliable, scalable, and repeatable high quality drone data. And I think that the reason for that is that the definition of how to collect high quality drone data hasn't really been cracked yet. And to some extent, there is so much information out there. There are so many different types of articles you can read, videos you can watch. In fact, we're culprit to this. We've got over 200 videos on YouTube at this point, that it can be easy to actually just drown in the noise with respect to what are the right things to do or right principles to follow when it comes to capturing high quality drone data. So in this video, what we're doing is we've actually identified the four main things you've got to keep in mind when capturing high quality drone data, and we're calling it the GOLD framework. Hi everyone, my name is Varun Sarwal from Hammer Missions, and in this particular video, we're going to go through the GOLD framework for capturing high quality drone data. We're calling this framework the GOLD framework because G is for GPS, O is for overlap, L is for lighting, and D is for distance. So if you forget everything else, and if you try and get four of those things right, the GOLD formula, you will essentially have great results. So let's have a look at them one by one. So first of all, we've got G for GPS. So GPS is really important when you're capturing drone data. The reason for that is that not only does GPS essentially allow you to automate your flight, which essentially ensures that you're going to get much better data as opposed to if you were hand flying everything, but also GPS is important because it gives your 3D model or your 2D map scale. And scale is really important when it comes to being able to produce those results that you can actually use for producing some form of action from. So if you're mapping a site and that's going to be used for some form of construction, having scale and appropriate measurements is really, really important. If you're actually doing inspection, even then, you've got to make sure that actually you're able to use scale so that you can establish if there are defects on a particular structure, what do you do about them, and how bad is the damage? So GPS is really important. We understand that it's not easy to actually get GPS on all flights at all times. For example, if you're capturing the underside of a bridge or if you're capturing a facade, sometimes you're going to get into these GPS shadows because inherently those structures block GPS. And in those scenarios, what we recommend is that you can use things like RTK to sort of essentially enhance the GPS signal. And it's really important to remember here that you're not using the RTK to essentially make the drone flight automated. You're using the RTK to essentially give the drone a better chance to write the correct GPS data to the metadata of the images, so then that can be used for processing and producing a high quality output. So G for GPS, really important to bear that in mind. Moving on to number two, we've got overlap. So overlap is essentially the shared region or the common region between every two photos in the drone flight. Now, we've done a whole video on overlap and in fact, even vertical overlap. And so I'm not going to dwell on it too much, but essentially the idea here is that when you're taking photographs for a 2D map or a 3D model in a drone flight, you're trying to ensure that every two photographs essentially overlap with each other. And this particular shared region or overlapped region is what's used in photogrammetry to create a 3D model. Once again, we've done a whole video on photogrammetry as well. So if you're curious to learn more about that, go and check out those videos. But overlap, especially the vertical overlap, which is the overlap between not just your sort of, 2D images, but your sort of, let's say the overlap between roofs and facades is really, really important. And so keeping that in mind is very important. Overlap is almost non-negotiable if you want to produce a stitched output from your images. Anything between 70 to 80% overlap, or in some cases higher, is essentially recommended. So keeping that in mind, O for overlap in that GOLD formula, really important. Number three, you've got lighting. So lighting is essentially also very much non-negotiable. If your subject, your site or asset is too dark, well, you're not going to see the detail. Equally, if it's overexposed, you're also not going to be able to get the data you need. So we highly recommend to make sure that you've got good lighting conditions. most of the times drone pilots ignore this, but if you essentially pay attention to the camera, which is essentially the device you're flying, and so if you pay attention to things like exposure, attention to things like whether you've got manual shutter or automatic shutter enabled, that would really help. And in fact, we recommend not flying in auto most of the times and flying in things like manual exposure or shutter priority, because that will help you ensure that even if you have drastic lighting changes on the day, your camera can actually sustainably handle all of that, and all of your images look crisp, sharp, nice, and good. That can actually be used for producing an output, producing a map or a model, or doing an inspection. And finally, we've got D for distance. Now, the distance is actually really, really important. In fact, it should really be up there with overlap. But in this formula, D's towards the end, and that's how this works. So distance is really important because distance to the site or the structure highly governs what is the resolution of the data you're going to be capturing at. You can imagine if you're too far from something, you're not going to see the detail. And equally, if you're too close to something, you may not be able to actually effectively fly the whole site. So finding the right balance and being the right distance from the site or structure is really important. And so the distance affects resolution of the data. And a good sort of mathematical way of defining this is GSD. So GSD is the ground sampling distance. And that's basically saying as you fly your drone on top of that site or in front of that structure, what you're doing is that every pixel in the drone's camera is capturing a little bit of the site or structure. So essentially, the surface you're capturing, the ground that you're capturing is being mapped in every pixel of the drone's camera. And therefore, GSD or ground sampling distance is defined as centimeters or inches, depending on which side of the pond you're listening this to, centimeters or inches per pixel. And so generally speaking, for example, if you're doing a building inspection, you'd want a GSD of something like 0.25 to 0.5 centimeters per pixel for the roof. And for the facades, you would need something like 0.25 centimeters per pixel to be able to see those deficiencies correctly. If you're doing thermal flights, you actually need a whole spectrum of different GSDs. And we've done a whole video on thermal data analysis. So if you're curious about that, go check out that video. But D essentially is for distance. Really important to make sure you've got the right distance so that you can see the right level of detail. And at the same time, you can keep your flight safe, compliant, and effective. So there you have it, folks. You've got the gold formula, GPS, overlap, lighting, and distance. It's not that complicated if you think about it. Just have to go out there, practice this a few times, make sure you've got good GPS, good overlap, good lighting, and good distance, and you start seeing repeatable results, and you'll be able to scale with those. Thanks so much for watching. If you found this video interesting, do share it with others in your community. We love producing these videos on drone data, and all we want to see is high quality drone data sets being produced repeatably so that the whole industry grows. And we'll see you in the next video at Hammer Missions.